Thanks,
And
everyone.
on that, our next presentation is going to come from Steve. He is going to show us what has been done to onboard Jenkins into Ortelius. And Jenkins is actually pretty clean. That team is doing a lot to keep their vulnerabilities down. So, Steve, I will let you take it away.
Alrighty. So, been doing some work on the UI piece, and this was mainly when we first did the rewrite, we were looking at how uh, projects were being deployed to endpoints. And then the requirement came around, let's go ahead and look at onboarding like Jenkins. Um, and one of the things that we realize is Jenkins doesn't get deployed by the Jenkins team. Um, it gets published to a release site, and then the end companies that are using Jenkins go out, download the new WAR file, and install it whenever they want. So there was this scenario where we actually have a release, but not a deployment. So that's what we're working on at that level. So in order to address that, we've made some changes at the what we call the organizational level. The organizations map over to like a GitHub organization or GitLab org. So it makes it, we're trying to keep that same concept. So we're not introducing new terminology. So if you're in the Git world, with GitHub or GitLab, Bitbucket, you have your orgs and then your repo under the orgs. So if we actually go into my profile, we can see where I have my different orgs associated. And because like something like Jenkins or the curl program project are public repos, I can actually go ahead and add in a just paste a new repo or um, just search for a particular repo and I can add that as a favorite. And when I add that as a favorite, our back end actually goes out and connects up to that repo. So there's a Kubernetes job that runs like, I think every 15 minutes that will go look for new releases that are happening for those repos that we told it to go ahead and scan. These other repos are coming directly through our GitHub app. So they have a different type of access over to the repository. So DeployHub's like a private repo, private org that we manage. So I can get into the private repos and do the interrogation of releases and deployments at that level. So we've changed up some of that, and we have the go ahead and connect now to your GitHub account button here that will go off and use the app integration. But like again, for like Jenkins, I'm not a member of, I'm not a maintainer of the Jenkins org, so I can't go and install the GitHub app into the org. So I'm going to just say I want to go monitor what's happening on the Jenkins side and bring that those releases in. Uh, this will happen with GitLab as well. GitLab doesn't have the concept of an application like GitHub does. So GitLab is going to follow more of the I'm give me your token to read this GitLab repo, and I'll be able to go ahead and scan that. So there is some information that we need to gather for access. We'll need a token on the GitLab side if you want to get to a private GitLab repo. We need a read-only token at that level. So if we actually go and look at back to the dashboard, I can go ahead and Look at my the filters. So my orgs are those orgs that I have that direct connection through the GitHub app. If I look at just like my favorites, I've added these to a favorites. I can also add any of my orgs. So if I go back up here and I can say I want Deploy Hub to be a favorite, now Deploy Hub's a favorite. So we're trying to scope, where you have hundreds of repos and stuff out there that you want to keep track of. I just want to look at a small subset. So a couple things that we've done is we'll kind of talk about the curl one and the Jenkins one. The curl one, this is a C, C++ code base. Jenkins obviously is Java. So we have a couple of different approaches that we've taken when we go out and scan those repos. Um, in the curl world, this curl doesn't really produce an artifact. They don't produce like an executable or anything like that. What they do is when they create a release, they actually go out and just publish that this is the tag, this is the release. These are all the files bundled together for this release of the source code. And if you want to go ahead and build curl, they give you the CMake commands to go ahead and build curl from that release. So you download it and build it yourself type of scenario. On the Jenkins side, Jenkins is going to create and publish the war file. So if we actually go over to Jenkins, we can see what's happening on that side. So Jenkins, for their war file, is published as a regular release out on GitHub. They have a new release candidate. We'll see how the release candidate is going to show up. This wasn't here yesterday. So for each release, we'll look at this more formal one. We can see that the war file's out here. And one of the things that we do is we can see that there's no SBOM out here. Same thing with the curl side, the C, C++ code, they don't produce an SBOM. So when we go out and find that there's a new release, for the war file, we're able to run sift or trivia, I can't remember which one it is, to produce an SBOM based on the war file. Over on the curl side, we actually have to run CDXGen, which is a Cyclone DX SBOM generator to generate the SBOM based on the C, C++ code and the make files and stuff like that. So you'll see that the what we get from the SBOM perspective is totally different between the two worlds. When we were at CDCon, we saw a couple presentations by the SBOMit, which is part of the OpenSSF group. They claim they can do a really high quality C, C++ SBOM. I have to get in touch with that group, that working group, to figure out how we actually hook that in for us to run that. Let's go ahead and dive into Jenkins. One of the things you'll see here, we're talking about post-deployment vulnerabilities. Because Jenkins, again, is not deployed, these values are all 0. But what we have in the pipeline is we can still get a post-release CVE, meaning that when a release was done on, let's say, June 1st, we have a CVE that shows up post June 1st, so let's say June 15th, that's a high or critical vulnerability that showed up post-release that will be able to do the same type of calculation. So I'm currently working on another dashboard that's release specific, giving you the same metrics that are needed versus the deployment. when things were found, how fast they're getting fixed, that type of MTTR type of cadence that we can track at that level. So obviously, when we go to the endpoints, that's blank. But if we actually go into the release itself, we can see the current version 570. That was the current release that's out there, and what type of vulnerabilities that it has. At this level, there's a GitHub advisory in commons.lang, a medium one. So Jenkins actually is looking pretty good. It doesn't have a lot of vulnerabilities in all the packages. And again, these packages, this SBOM didn't exist, so we generated it based on the war file. So we have all the versions, what is fixed in, cross-referencing with the OSV dev. Also, Jenkins does contribute to the OpenSSF scorecard, so we're able to pull the scorecard information as well at that level. Uh, if we go back to the versions, here's the one that just was released yesterday. So this is a release candidate that they're working on. And we can see that the release candidate actually is including critical vulnerabilities and some high ones. They're actually pretty good if we go back up and we can see this is the old release candidate that was out there, and then they patched the release candidate, got rid of a lot of the critical vulnerabilities, and then they finally did their real release, and they only had one medium vulnerability. So Jenkins is actually doing a really good job on the way they go through, create the release candidate, um, clean it up, and then they do their fix based on that. So some interesting things that we found at that level, watching what's happening with Jenkins. Um, so again, these are GitHub advisories that are out there, and we can see why directly what's happening with them. Now, we have not added in the reachability aspect of this. Um, so this advisory that is out there may or may not apply to the possibility of Jenkins being exploited through this CVE. It is we know that the package has it, and that's one of the things on the to-do list is to go ahead and bring in additional reachability, the CWE uh, information as well. And also, when I was out at CDCon, I talked to the another project called EPSS. The EPSS creates a probability score on whether a CVE is going to be exploited, or basically they're able to get some telemetry data from, I believe, like Palo Alto Networks to determine if this CVE is actually being exploited actively. And if it is, it bumps up the probability that you're going to get exploited as well, type of aspect. So we're looking at bringing in the probability score for exploitation as well. So I'm going to jump back over to any questions on Jenkins, and I'll jump back over to show you the difference between what we got going here and on the curl side. Alrighty, so let's go back over to the curl org. And again, the dashboard's empty, which we're going to fix. Other things we're going to do at the dashboard level, or actually at the component level, um, at this project release level, is we're going to bring in the SBOM quality metrics that John and Zadia were working on. So we'll be bringing in the quality of the SBOM at that level. So this one again was generated based on the um, CDX gen, looking at the code base. And part of that is you can actually see low-level C files. Um, One of the things with that is we don't know the version that SBOM generator. It works, but we get a lot of stuff that's missing. We don't know the version of it. We do know a couple of the packages that will pop in here. Let me see if they have any of the, this is all the source code dependencies. So it's okay. It gets us some of the information, um, but a lot of it is still missing. So we do know that we have a RPM kernel dependency. Um, and we do know the version of that. So when we get into the C++ code, noting the dependencies um, is interesting. Also, because when we do this SBOM generation for curl, the C++ code, it'll report back that it has a development dependency. So like on um, libs zlib, which is a compression routine. It'll give us a zlib dev dependency because that's what was available and being used at scanning time for the source code. But there will be also at runtime, there will be a different dependency that the SBOM doesn't catch on what the actual runtime dependency for zlib is and the version of that. So you can actually build this link to a one version of a dynamic linking to one version of zlib, and at runtime you have a slightly different version. So there are some gaps that we actually see based on this. And this is where I'm hoping the SBOM group is going to help uh, give us a better SBOM at this level. We can actually see, if we look at the history, that they did have some low dependencies that popped up, and I believe it's actually in curl itself. So these are actually curl low CVEs in the curl code base itself. So interesting that they actually are people are reporting actual vulnerabilities to the code base itself, all being reported as low, which is good. And then they get fixed. So if you look at which version is 820, and then 821, those are fixed. So the curl project's actually doing pretty good as well, keeping up with vulnerabilities in their own code base as ones that they bring in as well. So that's kind of some of the stuff that I found at that level around. Let's see if they generate an SBOM. Oh, they do an OpenSSF scorecard as well. So we're able to get that information for curl. So some of the things, just to kind of recap, when we go and look at uh, a, a a repo, we have a bunch of stuff that happens in the back end. We go and try to determine if it's like a C, C++. First, we determine if there an SBOM that exists anywhere. And if there is, we'll use that SBOM. And more than likely, there isn't an SBOM. So if it's a C, C++, we'll use CDX gen to generate it. If it's like anything other than C, C++, like if it's a Node, Java, a Python library that was released, we're going to use, I believe, SIFT to go ahead and generate those SBOMs if they don't exist. And if there are Docker images, we'll go in and do the same thing to a Docker image at that level. Some of the things that we'll do when we're trying to find those releases, we'll actually go and look at the workflows that have run. So if we actually look at the Jenkins workflows. They have a bunch of workflows that go out and run to do a bunch of stuff out there. They're labeling their publish artifact. That's probably the closest one that will go out and look at what's actually happening in the workflow level to determine if we can if they're creating like a Docker image and publishing it out to Artifact Hub, for example, or out to some registry, whether it's like Quay or GCR, ECR. We'll grab that information as well. So we're doing a bunch of logic behind the scenes when we go in and try to find a release and a deployment. One of the things that we'll also look at those workflow logs for is any deployment if they're doing a Helm deployment as part of that. In the works is GitOps. So if they create update a Helm chart with a new Docker tag for the chart, that's going to get pushed over to a GitOps repo. We'll use GitOps as a source of truth and pull out the deployment information from that level. One of the things when we get into GitOps that's missing is the where it's deployed to, because GitOps is a pull process versus a push. So we're going to have to ask the end user for some mapping, saying that this deploy up gets deployed to these 5 clusters in these 5 different zones in AWS, for example. So there's going to be some manual information that we need to get. If we have access to, we do have a Lambda and a Google Cloud run function that will look at the Kubernetes audit logs, and that will give us really accurate information about the deployment and anything about if it's deployed and has a attested SBOM to the Docker image. We'll pull that attested SBOM out and use that at that level. So we got a bunch of different methodologies. I wish there was one simple methodology to find deployments and releases, but each developer likes to get creative, and that's what we're kind of chasing down. But so far, it looks like we're getting the data that we need. So that's about it. If anybody has any questions.
So the work that you did with curl is that going to help HDF group? And you want to talk a little bit about what you're doing with Gerd and Garrett in the HDF group?
HDF group is going to be a similar way because it's all C++ code. And their platform engineer at one point did generate a C++ SBOM, and I got Garrett was going to look and try to get us a meeting with their platform engineer to see if they can turn their C++ SBOM back on.
So more work on adoption. Thank you, Tony, for introducing us to that group.
Yep. So actually, if you let me reshare my screen. If I go to public orgs, we can actually see Gerd brought in HDF5. So we've actually scanned their code. This is Gerd's personal repo that he branched and onboarded. So we're actually scanning their releases, and so far it looks clean. But I have to do more detailed analysis into their code base.